Hello everyone. Today's lesson is all about oxidation reduction. We're going to describe the process of oxidation reduction. We're going to identify oxidizing and reducing agent, and we're going to determine the oxidation number. Review vocab is spectator ion. Spectators are ions that don't really take place in the reactions. I mean, they show up, but they don't really take place in the oxidation reduction reaction. These are the terms that we're going to learn. Let's start with oxidation.
Oxidation reduction reaction. Any chemical reaction in which electrons are transferred from one atom to another, also called a redox reaction.
Okay, we're keeping track of electrons. Which one is given electrons and which one is receiving electrons, and that types of reaction is called oxidation reduction reaction. Transfer of electrons. So in this reaction right here, bromine goes from negative to zeros. Anytime you see an element by itself without charges, that's a zero right there. So it goes from negative to zero. So it lost an electron. So losing an electron, and chlorine went from 0 to -1, so it gained an electron. So you just by looking at it, knowing which one is giving up electrons, which one is receiving an electrons. The oxidation numbers is just a tool that scientists keep track of electrons movement.
Oxidation. The loss of electrons from the atoms of a substance increases an atom's oxidation number.
Okay, so the loss of electron increase in the oxidation number. That means you see sodium by itself is 0, 0 going to +1, that's a loss of electron, and it goes from 0 to +1, that's an increase in oxidation number. 0 to +1.
Reduction. The gain of electrons by the atoms of a substance decreases an atom's oxidation number.
Okay, so chlorine going from 0 to -1, that's a gain in electrons. And reduction is going from 0 to -1, the decrease in the number. Okay, so we remember the ionic compounds where it's a transfer of electrons. So that's the oxidation number of an atom is an ionic compound where there's loss and gain of electrons. Okay, this is what we just said. You gain. This is just the statement is right here. When you gain an electron, the oxidation number decreases, and when you lose an electron, the oxidation number increases. That's what this statement is. I like to give examples as we go. Oh, I put another example here. Okay. So from here it goes +3 to 0. Okay. That's gain of electron. I'm sorry, that's a loss of electron, so it's being reduced, and the oxidation number is also decreases. So it goes from +3 to 0. When it's being oxidized, it goes from 0 to +3, so that lost an electron. 0 to +3, and the oxidation number increase. So here oxidation number decreases, oxidation number increases. We're going to practice that a lot. So
Oxidizing agent. The substance that oxidizes another substance by accepting its electrons.
okay, whatever is being reduced is really an oxidizing agent. Okay, because it accepts the electrons. Oxidizes, accepting of electrons. Okay, so in this example right here, iron positive 3 goes to 0. That's a gain of electrons. It's a reduction, and it's a good oxidizing agent. So oxidizing agents are the ones that are being reduced in a reaction.
Reducing agent. The substance that reduces another substance by losing electrons.
Okay.
Reducing agent.
Oops.
The substance that reduces another substance by losing electrons.
Okay. Reduces another. Okay, it's being oxidized, but it reduces another. Okay, it loses its electron, and it's being oxidized. So for here, aluminum goes from 0 to positive 3. It lost an electron. It's being oxidized, and if it's being oxidized, it's a reducing agent. Now, in some cases, you might look at a reaction and you're not really sure which one is being oxidized, which one is being reduced. Okay, in this case, it might be, it's not really clear. So the best way to solve this is to refer back to the electronegativity chart. Remember this one from last semester? It increases as we move across. So now, as it turns out, the more electronegative, the stronger oxidizing agent. Okay, the higher the electronegativity, the stronger the oxidizing agent. So if you're not sure, we can look it up on its electronegativity, and we'll decide if it's oxidizing or reducing agent. Right, let's practice a little bit. We're going to look at half reactions, and we're going to look at some of these reactions, and then just going through molecules. All right, so the first one, oops, that didn't. All right, the first one is iodine going from 0 to negative 1. So 0 to negative 1, that's gain of electrons. And when it gains electrons, it's being reduced. And if it's being reduced, it's really an oxidizing agent. So in here, identify each of the following. Either it's oxidized or reduced. So again, it goes from 0 to negative 1. That's a gain of electrons, and it's being reduced. And if it's being reduced, then it must be oxidizing the other element. Sorry, this one didn't animate very good. So for K, it goes from 0 to positive 1. So that's a loss of electron. It's going through oxidation, and it's a reducing agent. It's reducing the other one. Now, in this one, we have 2. So we go from chlorine, 0 to negative 1. That's gain of electron. Okay, and then bromine goes from negative 1 to 0. Negative 1 to 0, it lost. So bromine lost an electron and is being oxidized. Chlorine gained an electron, is being reduced. Now for this one, we have to look into it. Iodine, it's in 7A, it gains an electron, so it's negative. So and magnesium is in 2A, it loses 2 and becomes positive. So we have to determine reducing agent or oxidizing agent. So magnesium goes from 0 to positive 2. So it lost an electron, and that's being oxidized, and it's a reducing agent. Iodine goes from 0 to negative 1. It gained an electron, it's being reduced, and it's an oxidizing agent. Okay, so you just have to keep track of one. If it loses, it's oxidized, and it's a reducing agent. All right, so what is this one? Oh, that's just identify oxidation reduction. Okay, so we have, this is where we run into spectators. Some of these are just don't belong in the oxidation reduction reaction. So let's see, let's keep track. Aluminum goes from 0 to +3. Iron goes from +3 to 0. So aluminum and iron. So you just separate the half reaction and ignore the rest. So we're going to ignore the oxygen. We're going to, yeah, because it doesn't take part of this. It's going to go from -1, -2 and -2. So we ignore those. So we have aluminum from 0 to +3. It lost electrons and is being oxidized. Iron goes from +3 to 0. It gained an electron and being reduced. So whether it's in just half reaction or a whole reaction, you just have to track them. It's nice to have color pencils actually to just keep track and stay with that color throughout the reaction so you don't get lost. Okay, so if aluminum is being oxidized, it's a good reducing agent, and iron is being reduced, so it's a good oxidizing agent. Okay, and if we look at the electronegativity, iron is 1.8, aluminum is 1.6. So iron has higher electronegativity. The higher the electronegativity, the stronger the oxidizing agent. Iron is an oxidizing agent. So sometimes if you want to double check if your answer is right or no, have the electronegativity chart next to you and just double check if you did it right or did you keep track of the electrons correctly. All right, and I think that's it for this section. Thank you guys. I'll see you next time.